Hello everyone, myself Snehal Shinde, lecturer in Pravin Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Utilization of Electrical Energy, Subject Code 22626, Unit 4, Electric Traction. So this is the trapezoidal speed time curve. So here Vm is the crest speed or the maximum speed attained in kilometer per hour. T1 is the acceleration time in second. T2 is the free running time in second. T3 equal to retardation time in second. Total T equal to total time of the run in second. Alpha equal to acceleration in kilometer per hour per second. Beta equal to retardation in kilometer per hour per second. S equals to the total distance of the run in kilometer. So acceleration is given by change in velocity during acceleration divided by time of the acceleration. So acceleration, it is denoted by alpha. So alpha equal to Vm divided by T1. So during acceleration, the velocity changes from 0 to Vm. So the net change is Vm and T1 equal to, so we will arrange this formula in terms of T1. So T1 equal to Vm divided by alpha. And next is the retardation. Retardation formula is retardation equal to change in velocity during the retardation divided by time for the free running. So beta equal to Vm divided by T3. So the during retardation, the velocity change from Vm to 0. So net change is Vm. T3 equal to Vm divided by beta. So T2 equal to the time for free running. So as we calculated T1 and T3 from the above formula, so the total time period is capital T. So we will minus T minus the acceleration and retardation time. So we will get the T2. So the T1 formula and T3 formula we have to substitute in this equation. So our T2 will become T2 equal to the capital T minus Vm by alpha plus Vm by beta. The area under curve gives the total distance travelled. So the area of OABC equal to S. So the distance travelled during acceleration in kilometer equal to the area of the triangle AOD. So half into base into height. So half into then T1 divided by 3600 into Vm. So equal to the half Vm T1 divided by 3600 kilometer. So distance traveled during the free run in kilometer. So area of the rectangle, that is DABE area, is Vm into T2 into 1 divided by 3600. So equal to we get Vm into T2 by 3600. And distance traveled during braking in kilometer. So area of the triangle CBE. So again half into base into height. So half into T3 divided by 3600 into Vm. So we get a final value of half Vm into T3 divided by 3600. So the next step is the total distance traveled S. So the distance traveled during the acceleration plus the distance traveled during free run plus the distance traveled during the braking or retardation. So from the three equation we have to add the distance traveled. So S equal to, we get this equation that S equal to half into Vm T1 divided by 3600 plus Vm T2 divided by 3600 plus half into Vm T3 divided by 3600. We know that T1 equal to Vm divided by alpha, T2 equal to capital T minus Vm divided by alpha plus Vm divided by beta. So small t3 equals to Vm divided by beta. So putting the values of T1, T2 in the equation, this one, we get this formula, that is S equal to half into Vm divided by alpha into 3600 plus Vm into 1 by 3600. So we will put the formula of T2 here. So T2 formula C here we have derived, we have to put here. Then again plus half into Vm into this T3. So T3 is formula Vm divided by beta. So like this we have substituted the value of T1, T2, T3 in the S equation, in this equation. So now we have to solve it. So Vm into Vm, we get Vm square. Okay. Then we have to multiply 2 into 3600. So we get 7000 into 7200 alpha. Then we have to add this plus. Then we get Vm into T. So we have to multiply this term in the bracket. So we get first multiply the first term. So first term is the T. So multiply Vm into T divided by 3600. So right here. Again we have to multiply Vm by this. So Vm into Vm by alpha. So we will get this value. Again this value with Vm by beta we have to multiply it. Then we get this value. Okay, then plus again this Vm square divided by B into beta into 2 into 3600. So simply in this step we have multiplied the terms in the bracket. So we get this equation, simplified equation. Now we have to take Vm into T by 3600 this side. Again this term in between here. Then minus here. We have to just arrange the equation that the square part is taken in middle. And 7000 alpha. Then beta, we have just arranged this equation. The upper equation is arranged in this form. So next is the Vm T divided by 3600 plus. So now the formula will be 7200 alpha. So here we can take this. This is the beta, this is the alpha. So we will take Vm square minus 2Vm square, 2Vm square. Then similarly here we will take Vm square minus 2Vm square. Here will be the beta, here will be the alpha. Okay. So next will be this step. So Vm by T. So Vm square minus 2Vm square we get minus Vm square. And here we get similarly minus Vm square. So this we have taken the formula. We have solved it. Then again we have to rearrange this equation. So first term will be the alpha. Second term will be the beta. And third term will be the capital T. So we have simply arranged this above equation. Now we have taken the Vm square by 3600 common here. So what remains in this bracket is 1 by 2 alpha. Okay, so see, by simply multiplying this you will get this term. So simply I have removed Vm square by 3600 to take this equation as a 1 by 2 alpha plus 1 by 2 beta. Okay, so plus this term as it is will come down. So taking right hand side to the left hand side we get, so simply we have arranged the equation. The some terms are taken in the left hand side, some terms are taken in the right hand side. So see, this minus Vm square by 3600 will come here and it will become plus. Okay, so this whole equation will come here and it will become the plus. So yes, it is taken. Then again plus Vm by Vmt divided by 3600. Now it is taken to the left hand side, so it will become from plus to it become minus. Then plus s will be as it is, then equal to 0. Simply we have taken this all right hand terms to the left hand side, taking right hand side to the left hand side. This is the simple steps. So now again we have divide and multiply 3600. So we have divide and multiply the 3600 term all over here. So now we will get, by multiplying, we have only multiplied 3600 to this equation. So just eliminate this part. So now we get Vm square 1 by 2 alpha plus 1 by 2 beta minus, again we have multiplied here 3600. So we get Vm into T. Again here was S term and we have multiplied 3600. We have multiplied this step because just to get rid of this equation. So to eliminate the divide numerator part and denominator part of the Vm, we have simply multiplied it with the 3600. So now this our equation is solved to this one. So the equation this is useful for solving the numericals. When we get the speed time curve numerical, so this is the useful one for solving the numericals. Now let 1 by 2 alpha plus 1 by 2 beta equal to the k. So simply we have substituted this value of 1 by 2 alpha plus 1 by 2 beta equal to k. So now our equation become Vm square into k minus Vm into T plus 3600s equal to the 0. So again we have rearranged the k term here. So we get Vm square minus Vm into T plus 3600s equal to 0. So this is the final equation. Okay, this equation is final. So again if we have to find, we can find this will be the A, B, C. So the formula like B minus root of B square minus 4AC divided by 2A. Our mathematical formula we will apply here and we will find out the Vm values. So our equation is useful for solving the numericals. So in this video we have found the speed time curve and how to find the Vm value. We have found it. So simply we have taken the trapezoidal speed time curve. In this we have divided into 3 parts: acceleration, retardation and free running period. So we have calculated alpha, beta, then simply the area formula, half into base into height, then in rectangular formula length into breadth we have find out. Then as we know the total formula S equal to this formula, so we have simply arrange area. Then again we have put the T1, T2, T3 values and hence we solve this equation and we get the value of Vm. Thank you.